The newly released images of the interstellar Comet 3 I/Atlas have generated an extraordinary wave of interest among astronomers and the general public alike, as they appear to show the mysterious visitor spitting out a dramatic jet of gas and dust toward the Sun, a behavior that perfectly aligns with what scientists expect from a natural comet. Although it might seem unusual or even alarming to see a long plume blasting directly sunward, astronomers emphasize that this is a completely normal part of comet activity, especially when such objects heat unevenly as they approach the inner solar system. The comet itself was discovered in late June and later confirmed by NASA in early July, quickly attracting attention due to its strange trajectory. Its orbit makes it unmistakably clear that 3I/Atlas did not originate from our solar system, but instead comes from an entirely different star system far beyond our own. This makes 3I/Atlas only the third interstellar object ever detected, following in the footsteps of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But unlike those earlier visitors, this object is far larger, measuring somewhere between 3 and 7 miles, 5 to 11 kilometers, in width, which makes it the largest interstellar object humanity has ever observed passing through our cosmic neighborhood. Its gigantic size, combined with its interstellar origin, suggests that it may be incredibly ancient, potentially billions of years old, perhaps even predating the birth of our own sun and planets. Because of these unusual characteristics, and because interstellar visitors naturally spark curiosity and speculation, a small minority of researchers have suggested controversial ideas, proposing that 3I/Atlas could possibly be an alien spacecraft or probe sent to observe Earth. Such notions have circulated before, especially with 1I/Oumuamua, which displayed a strangely elongated shape and unusual acceleration that some scientists argued could fit an artificial object. However, in the case of 3I/Atlas, the overwhelming majority of astronomers strongly reject the alien hypothesis, maintaining instead that the object is behaving exactly like a high-speed comet should. Nothing in the data so far requires any exotic interpretation. The new images captured on August 2nd by the 2-meter twin telescope TTT at the Tide Observatory in Spain's Canary Islands reinforce this natural explanation even further. These images, obtained through the methodical combination of 159 exposures, each lasting 50 seconds, create a clear and detailed composite view of the comet. In the composite, the icy nucleus of 3I/Atlas appears as a large dark disk surrounded by a glowing halo of dust and gas illuminated by sunlight. One striking feature stands out, a sudden, fan-shaped break in the circular glow, which marks the location of a powerful jet erupting from the comet's sun-facing side. In the Astronomers' annotated version, the jet is highlighted in purple, making its direction and shape easy to identify. The composite was first shared on October 15th through the Astronomers' Telegram, a platform commonly used by scientists for reporting transient astronomical events. Although the findings have not yet undergone formal peer review, researchers agree that the images provide compelling evidence supporting the natural behavior of the comet. Comets are well known for their glowing tails, which can stretch for astonishing distances, sometimes hundreds of millions of miles, in the direction opposite the Sun. These enormous tails form when the solar wind sweeps ionized particles away from the comet. Near the nucleus, however, comets can also release concentrated jets of gas and dust. These jets erupt when specific areas on the comet's surface heat up rapidly, causing volatile ices to sublimate and escape forcefully into space. Unlike the tail, which always points away from the Sun due to the steady pressure of the solar wind, these jets can point in almost any direction depending on which region of the comet is currently active, including directly toward the Sun. Although the idea of a comet ejecting material directly sunward may sound counterintuitive, it is actually a scientifically expected and well-understood process. Miguel Serra-Riquet, an astrophysicist and chief science officer at the Tide Observatory's Light Bridges Research Institution, explained via email that this phenomenon is entirely normal. The side of the comet facing the Sun inevitably warms more quickly, and if that surface contains a weak spot or patch of ice exposed to sunlight, sublimation can intensify rapidly in that region. This triggers a geyser-like eruption of gas and solid particles, launching them outward at high speed. As Sarah Rickett noted, jets point toward the sun, while the main tail always extends in the opposite anti-solar direction. The contrast between the two features, the jet blasting toward the star and the enormous tail stretching away from it, is one of the classic signatures of cometary behavior. Because 3I/Atlas is traveling through the solar system at an exceptionally high speed, much faster than typical comets bound to the sun. Its interactions with solar radiation and solar wind create particularly dynamic and visually impressive features. The jet observed in the new images may look more dramatic than what is commonly seen in ordinary comets, but the underlying physical processes are entirely consistent with natural expectations. The fact that scientists were able to capture such a clear image of a jet is especially valuable, as it allows researchers to study how interstellar comets react to our sun's environment. Since these objects originate from different star systems, the composition of their ices, dust, and organic molecules may differ somewhat from comets native to our solar system. Observing how jets form and behave under solar heating helps scientists better understand the structure and composition of these ancient celestial travelers. The age of 3I/Atlas adds another layer of fascination to the object. If it truly formed in an alien star system billions of years ago, and has spent nearly all of cosmic history drifting through the vast emptiness between stars, it carries within it ancient clues about the early conditions of other planetary systems. Every time an interstellar object enters our solar system, astronomers see it as a rare opportunity to study material untouched by our sun's gravity or heat. Unlike typical comets that orbit the sun periodically, interstellar visitors usually pass through only once, making every observation precious. Because of this rarity, images like those captured by the Tide Observatory become critical scientific records, offering insights that may not be available again for decades or centuries. Despite the excitement surrounding the comet, the idea that it may be an alien spacecraft continues to circulate in fringe discussions, often amplified by social media or sensational headlines. Yet professional astronomers repeatedly emphasize that extraordinary claims require extraordinary evidence, and currently there is no data suggesting that 3I/Atlas is anything other than a naturally occurring comet. Artificial spacecraft would likely show signs of controlled movement, radio emissions, reflective materials, or structural symmetry, none of which have been detected. The jet itself, while impressive, is a direct result of solar heating and matches patterns seen in countless other comets. Jets angled toward the sun are particularly common when comets experience sudden temperature differences across their surfaces, which is precisely what happens as they approach the inner solar system. Moreover, interstellar comets like 3I/Atlas move on predictable hyperbolic paths determined by their incoming velocity and gravitational interactions. These paths align exactly with natural physics and do not resemble the controlled directional changes one might expect from an artificial craft. The behavior of the dust and gas surrounding the comet also fits with well-known comet models, including the way solar radiation creates a glowing coma around the nucleus and the way changing rotational patterns can cause the jets to shift over time. As scientists continue observing 3I/Atlas over the coming months, they hope to gather more data about its rotation, surface composition, and the evolution of its jets and tail. Every new set of observations helps refine models of how interstellar comets behave in environments different from the stellar systems where they formed. Although the comet will eventually exit the solar system and resume its solitary journey through interstellar space, the information harvested during its brief visit will remain invaluable to researchers seeking to understand the diversity of objects that populate the galaxy. In this sense, 3I/Atlas serves as both a scientific treasure and a reminder of the vast interconnectedness of the cosmos. Even objects born around distant stars can wander across unimaginable distances and briefly share space with our world. The dramatic jet captured in the recent images is not a sign of alien technology, but rather a natural and beautiful testament to the physics of heating, ice sublimation, and cosmic motion. For scientists, it represents one more chance to study the ancient building materials of the universe, carried across the darkness of space by a comet that has traveled longer and farther than anything humanity has ever built.